So how do you teach a machine to fly a broken plane? And maybe more importantly, how do you ever learn to trust it with people's lives? Well, to find the answer, we're going to dive into this really fascinating document from over 2 decades ago that tried to solve this exact problem.
And here it is. This is a NASA contractor report from all the way back in July 2002. And what it shows us, loud and clear, is that this whole challenge of AI safety, it's not new at all. NASA was tackling this stuff head-on, right when the new millennium was just getting started.
And this really is the million-dollar question, isn't it? It's a question that's even more important today. If you design an AI specifically to learn and to change, how can you ever be 100% certain it's going to do the right thing when everything is on the line?
To really get the solution they came up with, you first have to understand the problem they were trying to solve. And we are talking about a true life-or-death crisis.
Just try to picture this for a second. A catastrophic failure happens during a flight. The plane's control surfaces, the very parts that let it fly, are suddenly broken or stuck. In that moment, the plane doesn't fly the way it's supposed to anymore. The rulebook is out the window, and the standard flight controls could be completely useless.
So the solution they proposed was something pretty incredible. An adaptive system, an intelligent flight control system to be exact. Now, this is not your normal autopilot, okay? This was an AI that could actually learn what was wrong with the plane as it was happening, and then create a totally new flight model right there on the fly, just to give the pilot a chance to land the thing safely.
So how in the world does a computer learn to fly a broken plane? Well, the answer was inspired by the most powerful learning machine we know of, the human brain.
And what's so cool here is how direct that inspiration was. I mean, look at this. On the left, that's a biological neuron. On the right, the artificial version they came up with. They both do the same basic thing. Take in information, process it, and send out a signal. And if you connect thousands of these artificial neurons together, well, you get a network that can learn. So here's the crucial part. A neural network, or NN, isn't like a regular computer program. It doesn't just follow a long, rigid list of if-then commands. Instead, it actually learns patterns and relationships from data. Kind of like how we learn from experience.
Now, this NASA report really dug into 2 types of these AI brains. First, you've got the pre-trained neural network, or PTNN. Let's call this one the student. It does all its learning in a controlled environment from a teacher, which is just a huge data set of flight info. Once it graduates, its knowledge is locked in. But then you have the online learning neural network, or OLNN. This is the improviser. This one learns on the job, no teacher, just adapting constantly during the flight. And that right there is the whole challenge. How do you certify the student versus the improviser?
So this incredibly powerful new technology created an equally powerful new problem. How do you prove a machine that learns is actually safe enough to fly?
NASA's answer was a super rigorous process called verification and validation, or V&V. As the report says, the whole point was to write the rulebook for certifying these kinds of complex AI systems. Now, those 2 words sound really similar, but the difference between them is absolutely critical.
I love how simply the report puts this. Verification asks, are we building the product right? According to all the blueprints and requirements. But validation asks a much bigger, more fundamental question. Are we building the right product? Is this thing actually going to solve the problem safely and effectively in the real world? You gotta have both. You just have to.
So what did this V&V process actually look like? Well, NASA basically built the ultimate safety checklist for its AI.
Okay, so the verification side is this very deliberate step-by-step process. First, you verify the requirements. Did we even define the problem correctly? Then the design. Is our plan to solve it a good one? Then you get into the nitty-gritty of the code itself. And finally, integration. Does this new AI play nice with all the other systems on the plane? It's really about checking your work at every single stage.
Validation, on the other hand, is all about real-world, high-stakes testing. They plan to throw literally everything they could at this AI. They'd push it to its absolute limits in worst-case simulations, they'd test how fast it could adapt, and then the final boss, a human test pilot, had to get in the cockpit, fly the system, and sign off on it.
So NASA's plan was just a masterclass in safety engineering. But even after all of that, the report admitted that one particular challenge pushed the very limits of what they even knew how to certify.
Remember the improviser, that AI that learns in real time? Well, for that system, the OLNN, the 2002 report pretty much says, yeah, we're not quite there yet.
They knew that certifying a system that is constantly changing while it's operating was a whole new frontier. They were honest about it and said that more research was needed.
You know, this 20-year-old report was basically a roadmap for trying to tame a ghost in the machine. But it leaves us with a question that's so much louder today. As AI gets more and more autonomous, in our skies, in our cars, in our lives, who is writing that final chapter on making it all safe?